we shall discuss about the units of concentration. Okay, in most of the chemical reactions, they are carried out in solution, and therefore we must know how to express the concentration of a substance in the solution. Okay, so the first one that we have is mass percent, okay, mass percentage or volume percentage, or we can also say mass percent, okay, mass percent and volume percent. In order to find out the mass percent or volume percent of any substance or solute, we just write it this way, that is mass or volume of solute, okay, divided by mass or volume of solution, okay, multiplied by 100. This is how we find out the mass percent and volume percent of a solute. Then the next one is molarity. Molarity and molality have a slight difference. In molarity we use the volume, in molality we use the mass. Okay, so molarity of a solution is defined as the number of moles of solute dissolved per liter, okay, of the solution. Once again, molarity of a solution is defined as the number of moles of solute dissolved per liter of the solution. So we denote it by capital M is equal to number of, okay, moles of solute divided by volume of solution. Okay, it should be in liter, and if it was in ml, okay, in any numerical problem, if it is given ml, then we shall multiply it by 1000, okay, in that case. And the SI unit of molarity is mole per liter, okay, or we can just write capital M also. Now molality of a solution, okay, molality of a solution is defined as the number of moles of solute per kg of the solvent. That is, we represent it by small m, which is equal to number of solute, okay, divided by mass of solvent, which is in terms of kg. If it was given in terms of gram, then we would have multiplied by 1000, okay, but if it is given in kg, we shall not multiply by 1000. And the SI unit of molality is mole per kg, okay. Now next one is formality, okay. Formality and molarity have the same value, okay. The only difference is that in formality, okay, we apply the formality only for the ionic solutes, okay. So formality is equal to number of formula mass of solute, okay, divided by volume of solution, okay. It should be in liter. If it was not in liter, if it was given in ml, then we will multiply it by 1000, okay. Now the next one is normality. Normality of a solution is defined as the number of moles of equivalent, okay, number of moles of equivalence of the solute dissolved per liter of the solution, okay. One more thing, yeah, liter is also equal to decameter cube, okay. So normality is equal to number of equivalent of the solute divided by volume of solution, okay. It should be in liter. The unit is mole per liter, okay, or we can write it as capital M, okay. Now what is this number of equivalence of the solute? So I shall write it here, number of equivalent of solute is equal to mass of solute divided by equivalent mass of solute. Okay, this is the thing. The next one is, see, equivalent mass of solute. So equivalent mass of solute is equal to molar mass of solute divided by valency. Okay, say suppose for example the solute is sulfuric acid. Okay, then the equivalent mass, okay, the equivalent mass of sulfuric acid will be, you write here the mass of sulfuric acid. Okay, write here the mass of sulfuric acid, okay, the molar mass divided by valency. Valency is 2. Okay, which means basicity. Okay, or maybe the amount of hydrogen that can be released. Okay, the number of hydrogen atom that can be released. So here 2 hydrogen can be released, that's why it is 2. Okay, so that is the thing. The next one is mole fraction. Okay, mole fraction of any component of a solution is defined as the ratio of the number of moles of that component divided by the total number of moles of all the components of the solution. Suppose if A and B are the components of the solution, then since we denote it by X, so the mole fraction of component A will be equal to the number of moles of component A divided by number of moles of component A plus component B. Okay, if it is for mole fraction of component B, then we should write it N of B divided by number of moles of component B divided by total number of the moles of the solution. Okay, total number of moles of the components of the solution. Remember that the sum of all the mole fractions, okay, the sum of the mole fractions of all the components, okay, that is XA plus XB will always be 1. Okay, it will never exceed 1. It may be little less than 1, but it will never exceed 1. Okay, maximum will be 1. The next one is relationship between normality and molarity. So here we have normality is equal to Nm, or we can write Zm also. Okay, where N or Z are the valency. Okay, earlier for normality I have given you an example of H2SO4 where the valency happened to be 2, isn't it? So these 2 we will substitute it here. Okay, so that way we find out the normality or molarity. Okay, if the molarity is given, then we just have to find out the valency and we can get the normality of that particular solute. I want you to solve this question, that is how many moles of NaOH are contained in 27 ml of 0.15 molar. Okay, this is the unit of molarity. Okay, NaOH solution. There is one more thing that I missed out regarding equivalent. Okay, equivalent mass of solute. Okay, I gave an example of acid, isn't it? Molar mass of acid. Okay, molar mass of acid, it will be basicity. Okay, if it was basic, it will be acidity. Okay, the denominator will be replaced by acidity, that is molar mass of basic will be acidity.